Hi, I'm Dr. Chris S. Crawford, creator of Neuroblock and director of the Human Technology Interaction Lab. Today, I'm very excited to announce that Neuroblock is now available to the public. Neuroblock is software designed to provide hands-on experiences for people new to brain-computer interface technology. It features a visual programming environment alongside interactive visuals of real-time physiological activity. Preliminary studies suggest that engagement with Neuroblock may help students gain interest in STEM fields. Work on Neuroblock started back in 2015. Back then, there was limited software focused on introducing K-12 students to brain-computer interface technology. However, we created Neuroblock in order to address that gap. If you're interested in checking out Neuroblock, please visit htulua.org/Neuroblock. To download Neuroblock, visit the link in the video description. Once you get there, you should either see a request form or a download button. If the request form is up, please enter your information and the download link will be sent to you shortly. Once the file is downloaded, open the file and follow the installation instructions. Once you have everything installed, you should see this interface. Neuroblock features 3 core panels. Starting here on the right side, you will see what we call the workspace. The workspace is where you're going to provide all of your code. This pane over here is basically referred to as the toolbox, and it has multiple categories. We'll briefly go through each of the categories, but we'll provide details in a later video of how to actually use each of these. The logic category is located at the very top. This category has blocks that you can use anytime you need your program to make a specific decision. For example, you can use an if block if you need to compare different statements. So I'm just going to go over this really quick. So if you wanted to do equal to, not equal to, greater than, less than, a conditional statement, this is where you find those types of blocks. Next, we have the loops category. The current version of Neuroblock only contains 1 block in this category. This block is commonly used anytime you need your program to loop multiple times. Next, we have the math category. This category is used anytime you need to perform any type of mathematical operation. Right under the math category is the data category. The data category includes blocks that contain processed brainwave information. In particular, these data blocks are called band power features. We'll share more about these features in a later video. Last, but certainly not least, we have the drone category. The drone category contains blocks that allow your program to control the drone. In particular, you can make the drone go up, forward, back, rotate clockwise. So you can use your imagination with this category. And the key here with Neuroblock is, for the first time ever, you're able to use a very simple approach using block-based programming like puzzle pieces to connect processed information from your brain to control commands to a robot, in this case, a drone. So using Neuroblock, your imagination, a drone, and a headset capable of measuring brainwave information, you can create your very first brain-computer interface application. In this video, I'm going to show you how to connect the Muse 2 device to Neuroblock. The first step is powering on the Muse device using the power button inside of the headset. So you look very close, you should see a power button in the inside. So you want to hold that power button down for a few seconds until you see this light flashing back and forward. Once you see that light, go into Neuroblock and press the Bluetooth button. The Bluetooth button is the blue button on this right hand side. Once you press this button, wait for a few seconds and you should see your Bluetooth device pop up. You're going to want to go and connect to that device, pressing the connect button, and wait a few more seconds, and after that you should see data streaming. Once the device is successfully connected to Neuroblock, you should see data over here in the top left pane. You should also see a bar graph over here in the bottom pane. If it looks like this is picking up noise, so in order to get it to pick up brain data, let's actually mount it. You want to make sure you're getting good contact behind the ears and also in the forehead area. The top left pane of Neuroblock features the real-time brainwave data coming from your connected device. The bottom left pane contains features that can be mapped to different physiological states. We'll talk about the meaning of each of these in a later video. In the top right corner of Neuroblock, you will find a set of menu buttons. At the very top is the play button. The play button should be pressed anytime you want to start your program. If you want to stop the program or land the drone, you can hit the stop button right below the play button. You can also hit the save button, which is located right below the stop button, if you want to save your progress or save a program to come back to later. Right below the save button is the upload button. Use this button to upload a program that has been previously saved. Below the upload button is the Bluetooth button. Use this button to connect to your Brainwave headset. Right below the Bluetooth button is information regarding the drone's battery power. Use this information to keep track of how much charge your drone currently has. The last core feature of Neuroblock is the trash can. Use the trash can anytime you need to delete code. Okay, so with that, you're now ready to get started making your first brain-computer interface application. In this video, we'll go over how to connect and test the Tello Drone with Neuroblock. The first step is powering on your drone using the power button located on the side. Hold this button down for about 1 second to power it on. Once the drone's lights start flashing, you're ready to connect the drone to your computer. Instructions are sent from the drone to the computer using the drone's Wi-Fi network. To connect to the drone's Wi-Fi network, simply update the network settings on your computer. After about 5 seconds, your drone should be connected to your computer. To test your drone's connection, feel free to use the sample program linked in the video description. Once you have downloaded the file, upload it to Neuroblock using the upload button. This program sends a takeoff command to the drone, waits a few seconds, and then sends a land command to the drone. If this program worked, then you have successfully connected to the drone. If you are running into issues, contact the email address listed in the video description. In this video, we'll show you how to build a simple program that moves the drone based on brain activity. Here's a screenshot of the final program you'll build in this lesson. You may notice that this program includes a block labeled beta. So what exactly is beta? To answer this question, let's first address the question, what are brain signals? Brain signals are measures of electrical activity in your brain. You will commonly see them represented using multiple line graphs. The x-axis of a graph showing brain waves usually represent time. The y-axis represents microvolts. Microvolts are a unit of measurement for tiny electrical signals generated by your brain. While this graph looks cool, it can be hard to understand what our brain signals are doing simply by staring at these lines. To better understand how our brains work during different scenarios, scientists often use advanced tools to extract useful information from our brain signals. One popular tool commonly used to describe our brain activity is called frequency band power. You'll also hear this referred to as frequency band. There are 5 different frequency bands commonly used to understand information hidden inside human brain waves. These frequency bands are important because they have been shown to measure states such as attention, drowsiness, frustration, mental workload, and more. For example, high delta power has been associated with deep sleep. Increases in theta power are often linked with states of deep relaxation. Alpha power is related to being relaxed but awake. Beta power is related to being alert and focused. Gamma power has been shown to increase during information processing and various memory tasks. Let's use our new knowledge of frequency band power information to build a simple program that moves the drone forward when our focus or mental workload levels increase. To get started, let's first get our drone to take off. To do this, click on the drone category and drag the takeoff block to the workspace. After receiving the takeoff command from our computer, the drone needs time to send instructions to the 4 propellers. To give the drone time to process the takeoff command, we will need to add the wait block. The wait block can be found in the logic category. Next, we'll need a way to make our program continuously send commands to the drone. To do this, we'll need to use a repeat block. The repeat block can be found in the loop category. For this example, we'll make our program loop 100 times. Since we know we want our drone to move forward, let's go ahead and grab the forward block from the drone category. Similar to the takeoff block, the drone will need time to process the forward block. So let's add a wait block after the forward block. If we simply add the forward and wait block inside of our loop block, the drone will go forward 100 times. At this point, you should test out your program to make sure everything works. To test the program, press the green arrow in the top right corner. Your drone should take off and go forward after waiting 3 seconds 100 times. When you're ready to land the drone, press the stop button in the top right corner. In this video, we'll show you how to add blocks related to brain activity to your project. To accomplish this, we'll need to grab an if-do block from the logic category. We will also need an operators block from the logic category. When we connect the if-do and operators block, we can get our program to trigger a set of code when a specific condition is true. For example, let's say we want to trigger the forward command anytime our beta power is greater than 10. To add this to our program, we can connect the if-do and the operators block. Next, we can update the operators block using the drop-down menu. To add the beta block, click on the data category. Next, drag the beta block inside of our operators block. To compare beta to a specific number, we can grab a number block from the math category. The last step for this section is to place our forward and wait blocks inside of the if-do block. This step will make sure that the drone only goes forward when beta power is larger than 10. We use 10 in this case just for an example. However, you may be asking, how do I know what value to compare beta with? To address this question, you can view the graph located in the bottom left corner of the Neuroblock interface. In this pane, you will see the power level of each frequency band represented in a bar graph. It is important to note that the average band power will change from person to person. It may also change from session to session, even when the person is wearing the brainwave device. One simple step to address this is to have the person relax right before starting the program. Next, check to see where their beta levels are. In the video shown here, you can see that the beta levels are going between these two numbers. In this case, we can set the number to a new value and challenge the user with trying to increase their beta power levels. One example challenge is to try to visualize and solve a difficult math problem with no pencil or calculator. You could also try counting backwards from 100 by odd numbers. Once you are ready to try moving the drone, press play and remain as still as possible. This is very important because moving can introduce other muscle signals that don't actually come from the brain. After getting comfortable with the program using beta and forward, feel free to explore other frequency bands and drone blocks. If you create something cool, please send it to us using the email address provided in the video description.